Imagine for a second that you could predict a superstorm. I mean, not just hours in advance, but with enough lead time to evacuate a specific neighborhood.
And do it 1,000 times faster than a supercomputer.
Exactly. Or picture a car that isn't just smart in the marketing sense, but is literally architected from day one to be a robotaxi.
It really does sound like science fiction.
Mm.
But if you look at the documents that came out of NVIDIA in late January 2026, well, that's the reality they're building right now.
It really is. And welcome back to the deep dive. We're looking at a very specific and explosive week for NVIDIA, January 26th through February 2nd. And the theme this week, it just feels different. We aren't just talking about chatbots writing poetry anymore.
No, we're definitely not. We're seeing a really distinctive shift here. It's a move from what everyone knows as generative AI,
Yeah.
ChatGPT, to what NVIDIA is starting to call industrial and physical AI.
Physical AI, that sounds heavy.
It is. It's about AI graduating from the digital world and really learning to understand physics, weather, robotics, AI that can actually touch things.
Okay, we have a massive amount to unpack here. We've got NVIDIA open sourcing their Earth-2 weather models.
Mm-hmm.
We have a staggering $2 billion investment into a company called CoreWeave to build AI factories.
That number is just incredible.
And we have to talk about the geopolitical friction that's bubbling up around China and a company called DeepSeek.
Yeah, that last one is particularly complicated. It raises a lot of questions about where you draw the line between open research and, national security.
For sure. But let's start with the planet. Let's talk about Earth-2. This news dropped on January 26th. NVIDIA released a suite of open models. Now, weather forecasting has been around forever. Why is this a tech story?
Because it completely changes the fundamental math of how we predict the future. Traditionally, weather forecasting uses these massive supercomputers to solve incredibly complex physics equations.
Fluid dynamics and all that.
Exactly. It's incredibly slow and expensive. What NVIDIA did with Earth-2 is shift to AI-based modeling.
So instead of calculating the physics of every single raindrop, the AI is, what is it doing? Looking at patterns.
It's looking at patterns. They train these models on decades of historical weather data, so the AI just learns how the atmosphere behaves. And the result is speed. Their medium-range model, Atlas, runs roughly 1,000 times faster at inference than the traditional systems.
Whoa, hold on. 1,000 times faster. I want to make sure I get the practical application of that. If a forecast normally takes an hour on a supercomputer, this takes, what, seconds?
Seconds, correct. And that speed, it's not just about convenience. It actually changes the science.
How so?
When you can generate forecasts that fast, you can do something called ensemble forecasting at a scale we've just never seen before.
Okay, break that down for me. What's ensemble forecasting?
It's all about probability. The atmosphere is chaotic, so a tiny change in the initial data can lead to a totally different storm.
Yeah.
So meteorologists run the model over and over again with slight variation.
To see all the possible outcomes.
Right. But usually they can only afford to run maybe 50 simulations.
Because the old physics models are just so heavy computationally.
Exactly. But with Earth-2, because it's so light and fast, you can run 10,000 simulations. You go from a rough guess to a highly detailed probability curve. You can say there's a 99.8% chance a hurricane hits this specific coastline.
That's huge for disaster response. But I saw something in the notes about downscaling and a model called CoreWeave. That sounds like a lot of jargon. What does that actually do?
This is, I think, arguably the most impressive part. CoreWeave. Think of it like those AI tools that take a blurry, pixelated photo and just upscale it into a sharp 4K image.
Okay, I get that analogy.
CoreWeave does that for weather maps. Global models are usually coarse, right? They map the world in big 25-kilometer squares, useless if you want to know if it's going to rain on your street.
Right.
CoreWeave takes that coarse data and uses generative AI to hallucinate the high-resolution details down to 2 kilometers, and it does it 500 times faster.
So it's turning a low-res weather map into a high-res reality. But does hallucinating the weather worry you? I mean, we all know generative AI can make stuff up.
That's a very valid skepticism. But in this context, the hallucination is constrained by the physics data it was trained on. It's filling in blanks based on probability, not creativity. And because NVIDIA open sourced this, scientists can actually verify it. It's not a black box.
That open source angle is really interesting. Who's actually going to use this besides, like, the National Weather Service?
Oh, energy companies, for one. They can predict wind farm output minute by minute. Insurers for real-time risk modeling. And smaller nations that can't afford a billion-dollar supercomputer can now run state-of-the-art weather prediction on a much smaller cluster of GPUs.
It democratizes the weather.
In a way, yes.
Okay, so we've got the AI predicting the physical world. Now let's talk about AI moving through the physical world, robots. On January 29th, NVIDIA released a blog titled Into the Omniverse. This feels like it's all about giving robots a brain upgrade.
That's a really good way to put it. For so long, robots have been good at just doing what they're told. Repetitive tasks.
Welding the same spot on a car frame a million times.
A million times. But they're terrible at improvisation. NVIDIA is pushing physical AI to change that.
And this involves world models. I keep seeing that term. Is that related to the weather models?
Conceptually, yes. A world model is basically common sense for a machine. You and I know if I drop a glass, it shatters. If I drop a rubber ball, it bounces. A robot doesn't know that.
Unless you program it explicitly.
Exactly. NVIDIA's new model, Cosmos, is designed to teach robots these physical interactions. It simulates outcomes so the robot can predict what's going to happen next.
So it can look at a scene and think, if I step there, I might slip, or if I push this, it'll fall over.
Precisely. It's reasoning about physics. And they've paired this with something called Isaac Lab Arena, which is basically a testing ground. Before you let a robot loose in a factory, you run thousands of simulations in the arena to see how his decision-making performs.
I was reading through the examples of who's actually using this, and it's not just research labs. Caterpillar was the one that really stood out to me.
The construction giant, yes.
They're integrating something called Jetson Thor. What is that?
Jetson Thor is the onboard computer.
Yep.
It's like the brain inside the machine itself. It's a compact little supercomputer made for robotics.
And Caterpillar is using it to build a cat AI assistant. Okay, Is this just Siri for a bulldozer? Because that kind of sounds like a gimmick.
It's actually a lot more complex. Imagine an operator in a massive excavator. It's loud, there's dust, and they're digging on unstable ground. Instead of stopping to look at a manual, they can just ask the machine, "Hey, cat, the terrain is feeling loose, what should I do?"
And the machine knows.
The machine analyzes sensor data, the resistance on the hydraulics, the slope, and it gives real-time guidance. It's about safety, and it closes the skills gap for new operators.
That makes sense. But the other example, Lem Surgical.
Yeah.
That one made me sit up straight. We're talking about robots performing spinal surgery.
We are. And this is where the precision of physical AI becomes, well, life or death. Lem Surgical is using the Jetson AGX Store platform to power a robotic system that mimics human dexterity.
Mimics is a strong word. Is the robot doing the surgery by itself?
No, not independently. The AI helps interpret sensor data in real time. It can tell the difference between tissues or detect resistance in bone with extreme sensitivity. The goal isn't to replace the surgeon, but to give the surgeon a tool that's steadier and more precise than their own hands.
It's just incredible, the range here from digging dirt to fixing spines. And then there were these social robots mentioned, Agibot and Intbot.
Right. And that uses those Cosmos models we just talked about to give robots a kind of sixth sense for human interaction. It's about navigation and social cues.
So if a robot is delivering mail in an office and sees me rushing down the hall...
Does it stop? Does it move left? Does it realize you're in a hurry? That requires a level of reasoning that standard programming just can't provide.
Okay, so to power all of this, the weather models, the robot brains, the surgical assistants, you need massive compute. And that takes us to the money, the big money. January 26th, NVIDIA announces a $2 billion investment in CoreWeave.
This is a really pivotal moment in the infrastructure of the entire AI economy.
For our listeners who might just know the big names, CoreWeave isn't like Amazon Web Services or Google Cloud, is it?
No, not at all. Amazon and Google are generalists. They host everything. CoreWeave is what people are calling a neo-cloud. They're a specialized operator of AI factories. They do one thing: high-performance GPU computing.
And NVIDIA bought stock at $87 a share. But $2 billion? That's a lot of cash, even for a company like NVIDIA. What's the strategic play here?
The stated goal is to build 5 gigawatts of AI factory capacity by 2030. And to put that in perspective, 5 gigawatts is roughly the output of 5 average nuclear power plants.
That is a staggering amount of power just for computing.
It is. But the strategy is what's so fascinating. By investing this $2 billion, NVIDIA is effectively funding the construction of the very infrastructure that is going to buy its next generation of chips.
It's circular.
It's a flywheel. It's vertical integration without technically owning the company. CoreWeave has committed to deploying NVIDIA's full next-gen stack. We're talking about the upcoming Rubin GPUs. the Vera CPUs, NVLink 6.
So NVIDIA gives them cash, and CoreWeave uses that cash to buy NVIDIA's most advanced, most expensive hardware.
Exactly. It secures a massive pipeline for the Rubin platform, which comes after the current Blackwell chips. It ensures that when these new chips roll off the line, there's a factory ready to plug them in on day one.
It reminds me of that old saying with the gold rush. You don't dig for gold, you sell shovels.
In this case, NVIDIA is selling the shovels, but they're also helping pay for the mine to make sure there's somewhere to use them.
Smart. But with great power, and 5 gigawatts is a lot of power, comes great geopolitical friction. And we have to talk about the DeepSeek controversy. This broke around January 28th.
Yeah, this is the story that had Washington buzzing. A U.S. House committee released a letter claiming that NVIDIA provided technical assistance to a Chinese startup called DeepSeek.
And DeepSeek has been all over the headlines for releasing a model that rivals the best U.S. models, but cost a fraction to train.
Correct. And that efficiency is really the heart of the controversy. The model was trained on H800 chips. Now remember, the H800 was the chip NVIDIA made specifically for China to comply with U.S. export controls. It's a slowed-down version of their top-tier H100.
So they followed the rules, they sold the legal chips.
They did. But the report says DeepSeek trained this huge model using only 2.788 million GPU hours, which is just shockingly efficient. And the concern from lawmakers is that NVIDIA didn't just sell them the hardware. They alleged NVIDIA provided technical assistance to help optimize the code.
To make it run that well on those slower chips.
Exactly. And the kicker is that this model was reportedly used later by the Chinese military, the PLA. That's where the dual-use dilemma hits really hard.
NVIDIA's stance on this is pretty firm, though. They say DeepSeek was a legitimate commercial customer at the time.
Yes, and they claim they had no indication of military use. And we have to be realistic about what technical assistance means. It's usually just customer support. Hey, my drivers aren't working, or how do I optimize this?
Right. If you buy a complex system, you expect the vendor to help you turn it on.
Of course. But the question lawmakers are asking is, should that knowledge itself be controlled?
Yeah.
If you help a startup optimize an algorithm for a chatbot, and that same optimization technique is then used by a military for tactical AI, did you help the military?
It's a massive gray area. You can ban a chip, but banning optimization advice seems so much harder to enforce.
It is, and it signals that the regulatory environment is going to get much tighter around these intangible transfers, software, advice, even open source code.
Speaking of risks, let's stay on that. On January 30th, NVIDIA's AI Red team released guidance on Agentic AI. This connects right back to our robotics discussion.
It does. We're moving from chatbots that just talk to agents that can do things, execute code, browse the web, control your computer.
Which sounds great for productivity, but honestly terrifying for security.
Well, yeah, if an agent can write code, it can theoretically write malware. If it can delete files to clean up, it might accidentally delete your operating system.
So what is the NVIDIA Red team suggesting?
They're pushing for sandboxing. It's a defense-in-depth strategy. You never trust the AI with direct access to your core system. You run it in an isolated environment, a sandbox.
Like a virtual machine.
Exactly. And you restrict its network access so it can't, phone home with your data. The idea is that if the AI goes rogue, it only destroys the sandbox, not your entire enterprise.
It feels like we're entering a phase where AI safety isn't just about, will the AI say something offensive, but will the AI crash my server or leak my corporate secrets?
That is the defining challenge of industrial AI. When AI touches the real world, the stakes are physical and financial, not just reputational.
Let's pivot to something physically tangible we might actually see on the road. Cars. January 29th, Mercedes-Benz made a splash with their new S-Class.
This is pretty significant. Mercedes is one of the oldest, most conservative car companies, and they are fully committing to the NVIDIA stack.
It says here the car is built on NVIDIA Drive Hyperion hardware and is Level 4 ready. Break that down. What does Level 4 actually mean for a driver?
Level 4 is high automation. It means the car can handle all aspects of driving in specific conditions without any human intervention. You could theoretically take a nap. This isn't just lane assist.
And they're not just selling this to individuals. There's an Uber connection here.
Yes. And this is the commercial kicker. NVIDIA is going to power premium autonomous rides in these S-Class vehicles through the Uber network.
So you open your Uber app, and instead of a guy named Dave in a Camry, a robot-driven Mercedes S-Class just shows up.
That's the vision. And it transforms autonomous driving from this R&D experiment that just burns billions of dollars into a commercial luxury product that actually generates revenue.
It really ties the whole week together, doesn't it?
It does. I mean, look at the progression.
We started with predicting the weather for the entire planet with Earth-2.
Then we moved to simulating robots and giving them common sense with Omniverse.
We're funding the massive factories to run it all with that $2 billion into CoreWeave.
And finally, we're putting that intelligence on the pavement with Mercedes.
It's a very cohesive picture.
It's the industrialization of AI. It's no longer just a digital curiosity or a homework helper. It is becoming the backbone of critical infrastructure, energy grids, transportation, heavy industry.
And with that CoreWeave deal, NVIDIA is making sure they own the pavement that this industrial revolution is driving on.
They are. And notice how they're open sourcing enough of the software, like Earth-2 and the robotics models, to ensure the developers build on their standards. It's a classic platform strategy.
Before we wrap up, I want to leave our listeners with one last thought. It came up on the periphery of these reports. On January 28th, NVIDIA advocated for a national quantum initiative. They're talking about merging AI and quantum computing.
That is the next frontier. If you think Earth-2 is fast now on GPUs, just imagine an AI model running on a hybrid quantum GPU system.
And with Agentic AI now able to execute code and reason, I mean, are we getting close to a moment where the digital twin of our world, the simulation we're building, becomes smarter or at least faster than the real one?
That is the billion-dollar question. Or maybe, knowing NVIDIA, the trillion-dollar question.
Indeed. Until the next deep dive, keep learning.